Hi there. Good morning, good afternoon, good evening, whatever time of day it is for you. Welcome back to the stream. We're gonna get back to work on our little game project here today. As usual, using the MonoGame framework to work on a fairly simple platforming game, which I only have a very vague idea of. Like, I want to... Obviously, it's supposed to be a platforming game where you can, like, run through the levels, defeat some enemies, possibly level up and collect items, like new kind of gear, equipment, stuff like that. We'll see. We'll just get the very basics down first, and then we'll just come up with some ideas that we can incorporate into the project. Hello Yannick, welcome to the stream. So yeah, I figured today, since last time we basically got the most important part of the physics done, I figured we could work on tile maps. Since that is like a topic that we can hopefully do in one stream. Let me just go ahead and remove the tile card here. There we go. And this time around I'm actually a little bit more prepared than I was last time. I did plan out some stuff. So I have a basic idea of what we're going to do in this stream. And actually, let me reiterate from what we did last stream. So last stream we basically implemented Box2D as our physics engine. But at the end of the stream, well, everything was basically working, but we had some problems with, we had to use very large force values to get stuff to move. And I said during the stream that was probably because we were using values that are way out of proportion, that are way too large. Because physics engines like Box2D, they obviously work with like real metrics, like meters, kilograms, and stuff like that to simulate the physics mostly realistically. But our game is obviously working with pixels, and we were thinking in pixels. And so we basically made our character here, the collider, the collision detection for our character, for example, was like 64 pixels in height, which is okay. But basically to our physics engine, that was 64 meters. And so basically our character alone had a huge surface area. And the physics engine, basically what it does is it calculates the mass by using the area and multiplies it by the density. And because of the large values, everything basically had a huge mass. So it naturally took a huge amount of force to get things to move. And to alleviate that, what I did was simply basically what I suggested last stream is we have a pixels per unit property here in our physics manager to convert from pixels to physics units and from physics units to pixels. And so yeah, then I basically included these methods for conversion, just for convenience. And then I simply, for example, in our collider method class, we just basically use these methods to convert the values around from physics units to pixels and vice versa. And that way, we no longer need those large values, and everything was kind of weird and cumbersome. But now everything's kind of smooth. It's not completely done yet, the physics system, obviously. We need, basically we need some handler logic for when collisions are detected and stuff, but we're not going to worry about that for now. So basically what we're going to do later in a different stream is extend this collider class by like callback methods that are called whenever colliders touch, whenever collision is detected, stuff like that. So we can add some additional logic there, but for now this is okay, and we don't need to worry about that. So we implemented the very, very, very basic player movement. Obviously there's not yet a jump animation. He's just walking on air basically, but that's fine for now. I don't want to worry about that now. We can finish that later. So the physics are working, and so that means we can start building the levels basically, and have the player walk around in the world and interact with it. So that's what we're going to do today. And I figured there's a lot of ways we can implement maps stages. Let me just decrease the volume of the music a little bit. And actually change the track here. Maybe this. Yeah, there's a couple of ways we can achieve this. We can do it all programmatically and basically just add the different tiles of the tile set here. Let me open up the tile set that we have. Actually, I think we have 2 tile sets in this asset bundle. Let me just see. Just a second. Let me pull it up. Tiles. There's one. Fairly simple. Just ground. But actually there's also a tile set of objects that we can place in the map. And yeah. And we have the same ones in a different color scheme. Basically for nighttime maps. So, yeah, and there's a couple of ways we can go about this. We could just add the tiles programmatically, like I said, but that's a little bit tedious and not very flexible, and we don't have visual feedback and stuff like that. So I figured, why not use Tiled, which is a tile map editor you can download for free. It's open source, I think. Yeah, and we can use this tool to just design our maps. And I just tried some stuff out here. Use this tool to design our maps, and then extend the MonoGame pipeline tool with an extension assembly to be able to process these tile map files that Tiled generates and turn them into instances of our own classes that are then responsible for handling the tile maps in the game. And that's what we're going to focus on today. And I have some ideas about this, and I actually came up with this plan here, just a small UML diagram that I threw together to showcase, or to have like a roadmap of how our level or stage system is going to work. And it looks a little bit, well, actually it looks fairly simple, I think. I was about to say it looks a little intimidating, but not really. So I kept this very, very raw. I didn't really detail it. I just wanted like a basic roadmap, so we have some plan and we're not too disorganized. So basically, the idea here is we have this scene manager class, which will be a game service. So there will basically only ever be one instance of this. And it's responsible for loading new scenes. And when I say scene is whatever you basically, the state of the game. A scene can be the main menu, a scene can be a stage selection screen, a scene can be the actual stage. Anything, any part of the game that is like its own screen, basically. And that's what the scene class is for. So a scene describes such a game state. And every scene will use the entity manager class that we already created to maintain and to manage the objects on the screen, add new objects and stuff like that, remove the objects. And we will have a scene definition class, which will be responsible for just storing the basic data of the scene. So what is the ID in order to be able to load it. So we can call the load scene method of the scene manager, tell it the ID, and it will look up in its collection of scene definitions here what definition there is for this ID, and it will tell the manager, okay, this is the path to the tile map, and we have this other class here that will handle the scene logic and stuff like that. So I'm going to go into a little more detail about this later, I guess, but the general idea is to follow this diagram here as a roadmap. And yeah, we're going to have to extend our game entity interface a little bit. And I think the very interesting part about this design is, what I want to do is I want to also be able to use the tile map, the tiled map editor, to place the game entities or game objects in the game world. And for that, I figured we could simply use this these object layers. I'm going to actually create a new map in a second here. We can use these object layers, and there are different types of objects in tiled. There are simple rectangles that we can place. There are these elliptic objects, polygons, points, which are just basically markers. And we're going to use these objects to basically tell the map that there's supposed to be a specific kind of game object there. And then when the map gets processed by the scene class, it will actually create the actual instances of the objects that we defined here using these generic objects. So basically, if I wanted to, let's say we have a class crate that describes like a wooden box that we can destroy, then I would put a point, this point object here, and say type game entity and entity. I misspelled that, didn't I? Entity. There we go. Name it, I don't know, box. And then here in these custom properties, I would then go type and specify the name of the class that should be instantiated. Like, I don't know, box or crate, something like that. So crate was the name of the class. And then this object would be instantiated at runtime. That's the idea. And we can also use these objects for collision detection. So obviously if you wanted the ground to have collision detection, we would add these simple rectangles over it and add collider as the type. And then when we process the map, we will check if the type is collider, and if so, we will instantiate a collider for that. That's the general idea. Fairly simple. And I also thought we should possibly change the way we handle the rendering just a little bit. Because if we do these, if we incorporate these tile maps, obviously, for example, this is a 100 by 100 tiles map. And that would potentially mean that we have a lot of sprites going on the screen. And I don't want to push the sprite batch to the limits. I don't know how many sprites the sprite batch can handle in one call. I don't know the limit, and I don't want to find out. So what we're going to do is we're going to have a separate sprite batch for each layer in the tile map. And for that, we're going to have to change our entity manager just slightly so that it can handle that. And I think that's actually the first thing I'm going to do. So let's go into the entity manager. And currently it's just always using the same sprite batch. So let's change that. What I'm going to do is I'm going to go into the graphics namespace and add a new enum actually. Let's say render layer. Change that to an enum. So let's say we have 10 layers. 10 predefined layers that we can use to render stuff. I think that should do. I don't think we don't even need that many layers. So that should be fine. So now here I'm going to add a dictionary where the key is the render layer and the object, the value, is a sprite batch. And there we go. And now we need to, I think in order to create a sprite batch, we need an instance of the graphics manager, I think. Let's see. Yes, graphics device. So we're going to have to pass that to the constructor here. Then we're going to initialize this dictionary. Let's create a method for that. I should do the trick, right? And obviously we need the graphics device here. There we go. So right after calling the constructor, we'll have a dictionary of a couple of sprite batches for each render layer. And that'll be fine. And now I'm going to go into the game entity interface, and we're going to keep the draw order, but we're also going to add a render layer. And this way, basically the draw order will be the order within the layer that the game entity is drawn. So it will be basically grouped by the layer and then ordered by the draw order. So let's go ahead. Where's the draw method? So obviously we no longer need the sprite batch here in the draw method. But what we'll need to do here is say group by render layer. And that'll return a grouping, so let's just say var. And then we can iterate over this grouping. And order the entities by the draw order. Whoops. Order. There. And then we can draw them. And we will draw them using the sprite batch from the associated layer, which will be which we can get this way. And there we go. And that's basically it. That's all I wanted to change. Now, obviously, we have to adjust our player class here since it doesn't have that property. But I guess I can just simply go and add it as an auto property. And for now, we'll just assign render layer, let's say 2 by default. I guess I forgot something. Well, first of all, I will need to also adjust, let's just say, go to implementation. Wait, that's it? Right, we only have the player. Okay, never mind then. Okay, but in the entity manager, I just grouped by the render layer, but I did not order them by the render layer. And we'll see how that works out performance-wise. The grouping and reordering. I guess if it's too many objects, that'll impact the performance a little bit, but we'll see. Maybe it's not that big a deal. Where is it? There. So here I'm grouping it, but I also need to order it. I need to order the grouping by the key. which is the render layer. And if I give the render layer values, which by default, one will actually have the layer, the value 0. So I guess that's fine. So when it will be ordered, 1 will be the first one to be drawn, and then 2, 3, and so on and so forth. So I guess that's fine. But we forgot to close the parentheses here. And there we go. That's fine. Now, what do we need to do next? First of all, we kind of need to study the file format of those tiled maps. And there's actually an official documentation, but it's fairly simple. It's just XML. And a little bit of CSV, so it's really simple. So that's why I created this test map here, and I actually open it up here in Notepad++, and this is what the file looks like. So here, this is the map, and obviously I just added these, so they're not in the Notepad++ editor yet, but it's just a mostly empty map with a rectangular ground shape here, a little bit of stuff going on down here. Fairly simple. So if we take a look at the representation here, it's actually quite obvious. So first we have the definition of the tile sets that I used, and they're basically just referenced here. There's this source attribute in the tile set element with an actual path, a relative path to the file. And in this case, it's in the same directory, so it's just the name of the file. And then there are the layer definitions. So a layer element, it has an ID, it has a name. The name is what I entered here, or the default name if I didn't enter anything. Width, height, and that's it. And then it's just a bunch of identifiers for the tiles in the map in CSV format. And down here you can see 8888888, 1313 1313, and that's just the identifier representation of these tiles here. And we can use that information to be able to draw the correct sprites on the screen. And that's the plan. And for objects, it's also very simple. All that happens is it adds an object layer here somewhere, or an object group. Yeah, it's called object group for some reason. In the editor, it's called object layer, but here it's called object group. So it adds an object group with some object elements, and that's it. And we can parse through that. Actually, we don't even need to manually parse it. We can just deserialize the XML into some temporary class, basically, and then use that object to create our actual tile maps. So yeah, how do we start? I guess first of all, let's go into Visual Studio. Collapse all. So I'm going to add a project here for extending the content pipeline so we can actually import those tile maps, because MonoGame does not by default support that tile format. But that's fine. We need to basically tailor our own solution, and that's fine. So what I'm gonna do is go here into the console, and I'm gonna say .NET new, and I forgot what it's called. They all start with MG and then something. I think it was MG content, but I'm not sure. So let's see. Let's just enter .NET new. and it should list all of the available templates that I have installed. Yeah, there it is. MG pipeline, that's what it's called. So this will create a new project, just a library with pipeline extensions. So let's do that. MG pipeline. And we need to specify the output file. I'm going to say Ninja Game pipeline. Template was created successfully. That's great. So we need to add it now. Oops. Add existing project, and it should be. There it is. And I think I tested this actually beforehand. Yeah, something is wrong with the dependencies here, and I think that's because of the fairly recent release of MonoGame. It's actually 3.8, and I was using 3.7 here. There, MonoGame 3.7. Yeah, 3.7. So we're going to change these NuGet packages. I'm going to just remove them. I think they're actually just placeholders. They're not actual NuGet packages that actually deliver content. So let's remove them. And add the correct ones. It should be that's MonoGame extended. That's not what we want. MonoGame framework content pipeline portable. That sounds fair. Should be correct. I mean, technically, we don't actually need this specific assembly to be .NET Core. We could just use .NET Framework for that because it's just a pipeline tool. It's not part of the actual application. It's just a separate tool that we need to process our game assets. So it doesn't even matter that much what kind of project it is. But anyway, I think we also need to add the MonoGame NuGet package itself. So the portable version there. And I think that'll do. Let's see. It already created a stub for an importer to give us a starting point, but I always think it's really weird that they use this alias up here. I mean, you can do that, but it's just confusing. Why use an alias here for the string? That's just weird. So with this, we can basically tell the content pipeline tool how to handle specific files. And that's awesome and that's great, and we're going to need that to process our tilemap files. And let's think about this really quick. Let's take a look here. I guess in the first step, we simply need to deserialize this XML and CSV data into some object. Technically, we don't really need to. We could just, for example, use the xDocument class to just deserialize it into a generic XML object and then work with that. But I think it's easier and more maintainable and understandable, I guess, to actually model this this data here as an actual class. I think that's actually a better approach. So let's start with that. Let's basically create a class that just encapsulates the data that we see here. But I guess we will have to start with the actual tile set, because in here there's just a reference to this tile set, which is also a custom file format from that Tiled provides, but it's actually just another XML file. So as you can see, it's really simple. It's just one element, a root element named tile set, which defines the name and the dimensions of the tiles, the number of tiles there are, the number of columns, and that's it. And then a reference to the image with the actual tile set. So that's it. So let's create classes to encapsulate this. And these classes will actually live in that new assembly because they're not actually game data, they're just for deserialization, and that's it. So first of all, let me rename this. Let's call it tile set importer and tile set processor. And just to check with you guys, is the audio okay? Is the visual part okay? Can you read everything on the screen? Is the music too loud? Just give me some feedback here so I know that everything is okay, or if I can improve something. Looks good to me. Okay, thank you. Thanks for the feedback. And you can hear me okay? I guess that proves that you can hear me okay. Otherwise, you wouldn't have known how to answer. So that's fine. So I just really can't tell if the music may be too loud. I mean, from what I can tell in OBS Studio, it looks like the volume is fine, but it's hard for me to tell. So, in order to distinguish between actual tileset classes, because there will be a tileset class, and just the deserialized data, I will not name this tileset, I will name it tileset data, to indicate that it's basically just a data container. And it doesn't even need to be public, we can keep it internal, because it's just a temporary data store. So let's have a look. We have a version, which I don't even think we need. I mean, possibly, but most likely not. Let's include it because it's not a big deal. Whoops. We're probably not going to need it. tiled version. Come on, let's put it in there, even though it's probably not even of interest. But the name and tile width and tile height is very important. With the name, not so much, but the tile size. Hi there, Nightbird. Glad you could join the stream. I'm actually doing fine this evening. I had a little bit of a stressful day at work, but evening so far turned out fine, so I'm looking forward to some coding here. I hope you had a wonderful day as well. We need the tile count and the column count. So just to give you a brief update, I fixed the few issues that we had with the physics that we had last time. Basically, the only problem we had was that we used way too large values because we were thinking in terms of pixels instead of real metrics like meters and kilograms. So I added conversion logic. Very, very simple. Just some conversion methods in the physics manager to convert pixels to meters and meters to pixels, and so on and so forth. And with these conversions, everything is working just perfectly fine. Also, what I did, I think last time we actually used a Box2D version that was targeting the .NET framework instead of .NET standard, because our library here is actually a .NET standard library. And it did work, but you shouldn't be doing that. So I retargeted. I basically used a different package that was actually more up to date, which is targeting the .NET standard, I think 2.1. So basically I upgraded the assembly to a 2.1 assembly, .NET standard 2.1, and then I could reference this Box2D.NET standard NuGet package. Yeah, so it was really an easy fix. So basically, if you think about it, the physics engine, it calculates the mass of each object by simply multiplying the surface area, or not the volume, by the density. And since we were thinking in pixels, but the physics engine is using meters, everything had just a huge volume and therefore a huge mass. And naturally and logically, if something has a huge mass, it just needs a huge amount of force to be able to move it. So yeah, so we had to use these really, really enormous values. But now with the conversion, it's working fine. So let's get going. Yeah, so we'll fix this. I guess we can already specify the type. Inconsistent. Yeah, this is public. Yeah, but the tile data is not public, so I guess we have to change it to public. And there we go. And for the tile set, that's it. Oh no, there's also an image in the tile set, which has a source attribute and width and height, and that's it. And the simplest way to handle the deserialization would be to use the default XML deserializer or XML serializer from the .NET framework. And in order for it to work optimally, we should use the appropriate attributes here in these data container classes. And I forget the namespace. I think it's system data, but I'm not sure. Oh, it's actually system XML. And I think there should be XML indicates that a public field or property. Nope. XML, what's it called? XML type. Nope. XML root. I guess on the actual class name we don't even need that. We can just go here and say XML element. Actually, this is not an element. This is an attribute. The image is an element, but source is an attribute. And so are width and height. So let's say so we need to tell the serializer that these are in the original file, these are actually attributes, so that it knows how to deserialize it. And I guess we can also specify the name, but I think if we don't do that, it just assumes that the name of the property is also the name of the attribute. Not sure if it's case sensitive, we'll have to see. I mean, we can just be completely safe and say attribute name source. But I think by default it will just use the property name and not be case sensitive. And there we go, and same thing here. We actually need to add the image. These are all attributes, right? Yeah. There should be a code snippet for that. And maybe there is. It's in a different namespace. Named. Oh. Gets us this data type of the element. There we go. And this should already work. I mean, it's just basic deserialization. I guess let's test this by simply adding a unit test project. Wait, what is this targeting? This is actually a .NET Framework library. So the pipeline extensions here are targeting the .NET Framework, but everything else is handled using .NET Core. But yeah, that doesn't matter because Pipeline 2 is just a separate external tool that has nothing to do with the actual game application, so that's fine. So let's test the deserialization. Oh. And I guess I'll just use this one, test.tsx. I will just go here into the folder, add a folder, let's say resources, and then I will add that. One. It's funny that it thinks it's a TypeScript file because of the extension. TSX, I think. So let's load that file. File content equals system IO file read all text, pass constant, and we'll just assume content. That's funny. We'll just assume that that works. And then we'll deserialize that using the XML serializer. And again, I forget what namespace it is in. Hold on, let me look it up. There should be a class XML serializer, but I forgot the namespace. there's a separate assembly, system XML, which I need to reference. Well, I guess I can do that, that's fine. You could also add the reference as a NuGet package. And I think that would actually be smart. But that's okay for now. And to the constructor, we need to pass the type of the object that we want to serialize or deserialize, which is tileset data, which is in a different assembly. So let's add the reference. There we go, and now we should be able to deserialize the file content. So let's say tileset data, serializer, deserialize, and I think it needs a stream. We can either use a file stream, or we can now use a text reader with the file content that we already have. But let's just use a file stream. And I think pass the path. Oops. The mode should be read. Why is there? I mean, it's great to have this many options, but I kind of hate it when there's a constructor with 15 overloads. I mean, instead of having 15 constructors, they could have just create a few basically factory static methods. But oh well. Serializer. So obviously we don't need this anymore. Ah. Serial. Need to cast it because obviously the deserialize method just returns an object, because how are they supposed to know that it's of type tileset data? And let's see if this works. I don't see why it wouldn't work. So let's just assert is true. And I guess it worked if the tileset data is not null. It's in the scope of the using block. Whoops. It's not null. And let's look up. The name is test. Width is 64 and height is also 64. Let's check for that. And oh, tile set data. Yeah, that's fine. That'll do. Let's run that test. I don't see why this wouldn't work, but sometimes, you know. It doesn't, so let's see why. Path not found. Oh. It apparently doesn't work with relative paths. I wasn't aware of that. I guess probably we can do this. Then maybe it might work. If not, then we'll just use an absolute path. Whoops. I didn't mean to start the game. Nope. Oh, actually, hold on. It did use a relative path, but there was still something wrong. Oh yeah, I know why. Obviously, when this gets built, it doesn't actually copy the resources into the target directory. So let's go here and say add existing item. All files there. Actually, hold on. Exclude. Add existing item there. And now I need to tell it to copy it when it is built. Here, and it actually thinks it's a TypeScript file, and it the default build action would be to compile the TypeScript file. That's funny. But no, we want to just copy. Oops. Build action. Content. Copy to. Copy of newer. Ah, again I started the game. Whoopsie. Yeah, so now it's working, and tile set XML and S wasn't expected. Why? Wait, what? I don't even see this here. What are you talking about? Tile set XML namespace. That's funny. Oh, yeah, I know. We forgot something. We forgot to tell it that this is the root. Yeah, okay, obviously. So since we didn't tell it, since we didn't use the XML root attribute, it would just assume that the root element would actually be named tileset data. Ah, and again I started the game. Whoopsie. Debug. Let's just make sure this works. Yep, there we go. Now let's take a look. Looks fine. Columns 5, which is, I think, yeah, 5, tile count 50, 64, 64, and that's okay. Tiled version is null, which is weird, but it's probably because I made a typo. Because everything else seems to work. And actually, we don't need that tiled version. Oh yeah, the V should be lowercase. Actually, we don't care what tiled version was used, so. But I thought it's just, I don't know, a handful of attributes, so why not include all of them? Yeah, so now it's working. So now the assert should actually succeed. Yeah, that's fine. Okay. Okay, so that's working. So now we need to do the same thing basically with the tiled map. And for the first step, we're not going to think about processing the data. We will just simply deserialize it as is. And then in the second step, we will process that deserialized data into actual useful instances that we can use in our game. So, the root element is named map. I guess we will have to focus on only the attributes and elements that we actually need. For the tile set, I included the stuff we don't need because there were so few attributes, so it didn't really matter. But for now, I want here to focus on only the ones we need, since otherwise we're going to spend an eternity. So we don't care about the orientation because it will always be orthogonal. And what that means is basically tiled also supports isometric tile maps. But since our game will not use isometric tile maps, they will always be orthogonal. Let's not care about that. And also let's not care about the render order because we will handle the rendering ourselves anyway. We don't care what this says here. We don't care about this infinite attribute, whatever that means. We don't care about... Well, I don't know what these are for. I would probably have to look that up. Next layer ID. Oh. Yeah, okay. Next layer ID. That's only... these are only used in the editor. Here in tiled, so that it knows when I create a new layer now what ID to assign. So we don't have to care about these anyway. We don't have to care about these either, and I don't know why it keeps jumping back here. So let's forget about these. So what does our map actually need? The width obviously is very important, and so is the height. And tile width and tile height are also very important. And that's it. I'm surprised it doesn't have a name. But okay. I guess they are probably generators that generate a class from either an XML example file or like an XSD file or something, but never mind. Width, height, and that's it, right? Yeah, that's fine for now. I hope this doesn't take too long so we can focus on the actual processing of the data. Yeah, it's all lowercase, right? Yeah, it's all lowercase. So I guess this is the boring part. It's just a bunch of copy paste. But hey, we need to basically define a kind of data contract here. And now it needs a reference to the tile set. Yeah, let's not think about this too hard. It's just deserialization. Let's just keep it as it is. First GID, that's very important because I looked that up in the documentation. How they handle the tile references here is 0 always means there is no tile, so it's basically transparent, it's blank. And when you reference a tile set here, for example, this test tile set, it basically determines that the first tile in that tile set will have the global identifier 1. So when I use, when I place a tile from that tile set, this would be global ID 1. It's right here. I hope you can see that. This would be ID 1, and then 2, 3, 4, and so on and so forth. And if you take a look here, then the next tile set will start with the global identifier 51. And it'll be the same thing. So basically it's just, it tells the tile map how to start numbering the tiles, so that it can be uniquely identified within the tile map. And that's what this huge matrix here is. Okay. I'm not sure. It's fine. actually first. And that's it. It's a little bit of a pain to create these just data container classes, but we're going to need them. And like I said, we could just deserialize it into a generic X document, but then it will be a pain to work with that. And so we'll just crunch through these data container classes, and then we can focus entirely on the processing. Yeah. How does it handle? How does it handle reoccurring elements? Can I just add that as a list or some sort of collection? Like, let's use the iCollection interface and go. Well, I guess we can just. Not sure how it handles arrays off the top of my head, but it's probably fine this way. Tile set. Let me actually look it up here really quick. I think it should be fine. Pretty sure this is fine. Okay, now we get to the layers already. Layer has ID, name, width, and height. Fairly simple. ID, name, width, and height. Not is the ID always numeric? I guess. Yeah, it is. I guess we possibly might not need these XML attributes. If I guess we can specify in the deserializer some sort of naming strategy, and can just tell it to always use lower cases. But now we're already way into modeling it, so Never mind. So how's the volume of the music? So for me it's okay, but I don't know about you. I know I keep asking that, but sometimes I'm just not sure. And that's fine. Go into the tile map and add the layer data, layers. And for everyone who just joined the stream, because I saw that we got a few new viewers here, first of all, welcome. What we're doing today is, for our little MonoGame platformer game, is we're going to integrate or implement tile maps that we create with the tiled tile map editor. So, and for that, we need to extend the MonoGame content pipeline by a custom content type, which will be the tile maps and the tile sets. And we're currently in the process of creating that extension. And yeah. So the first step is to basically just make sure that we can deserialize the XML files here into a data structure, and then we can process that data and turn it into actual functional objects. So these are just data containers, so don't worry about them. Okano says, tiled is neat. I personally prefer Ogmo. I think I've used Ogmo years ago when it was... I've tried it once, but I hardly remember. Let me look it up. Ogmo. Okay. I'm just curious. Documentation available here. Okay, it looks neat. I like the UI a little better than I like the tiled UI. The tiled UI looks a little bit... It has improved. It was a little bit more, let's say, basic. But it has improved. But yeah, I mean, I guess it's a matter of preference. I'm always very happy with what tiled can do. So it'll do the trick. And very important is that our layer will need the... So this is basically the most important part, the tile matrix. It's really just a matrix of IDs in CSV format. And I guess we can just have that be a string property of the layer, since we really want to tailor this to our needs. We want, I guess I like to keep stuff reusable and generic, but we're never going to use any other encoding than CSV. Because let me show you what other encodings there are. Map properties here, CSV, and the other options are XML, which is deprecated, base 64, which is basically, I guess, CSV as a base 64 string, and then the same thing, gzip compressed, zlib compressed, or zstandard compressed. So I don't see a reason to store this as a base64 encoded string. So for that reason, let's just go into the tile map layer data and add this as a string. So basically what I'm saying is we can ignore this attribute. Okano says, I like it because I can define object templates for my artists to use so they don't have to make fields for every object. I think Tiled has a similar thing. I've actually never used it, but I think it does have templates. Here, insert template. I don't know if it refers to the same thing, and like I said, I've never used it because I didn't have to. But it does have a concept of templates. I can't tell you too much about it. Basically, I just can tell you that it exists. But yeah, I think it's a fairly new feature to Tiled. So there we go. That's a huge chunk of the file done. And now object groups. Those are also very important because we need them to spawn our actual game objects and the and handle the collision. Oh, but actually the layers... Oh, wait. Okay, no, never mind. We're good. So I guess there can be multiple object groups. Obviously. So... It's also an interesting one. It's, I guess, so far the most quote-unquote complex data structure. It has an ID and a name. I really need a snippet for this. Quick poll. Whenever you have an ID property in C#, keeping in mind the C# naming conventions, do you name it like this? Or do you name it the way I did, with a lowercase d? Which way do you usually go? I usually go like this. Because this way, it's all caps and it looks like a constant. Let me hear your preference. Oh, there's way more. How did I miss that? Oh no, that's the object group. Object group, yeah, that's fine, okay. And now the objects, most important. Let's just put it here. Also has an ID. And I guess technically we could use inheritance here, but that's a little unnecessary and ridiculous for just data containers. All right, it's getting late. Yeah, no worries. Thanks for stopping by. Thanks for hanging out. Yeah, thanks. Always glad to have you here, and have a good night. See ya. Everyone else, we'll keep going. We'll keep working on this. I don't know how long I'm going to stream tonight. We'll see. There's no time limit. I have the entire day off tomorrow. No work. Nothing planned, let's say it like that. ID, name, type, XY, width. The type is going to be very important later on. XY, width, height. And that's it. And the properties are also very important because we're going to need them to basically initialize our object instances, our actual game objects that interact with the game world. That's what we're going to use these custom properties for. Man, C# seems tedious having to write getters and setters for everything. Well, actually you don't. I mean, that's why I use auto properties to not be have to write getters and setters. Like, I don't know, something. I mean, this is basically short for, well, I can just convert it for this. So you have a field something, and then you have a property with a getter to get the value of the something field, and then the setter to set the value of the something field. But if there's no additional logic in either the getter or the setter, you can just use an auto property, so that way you don't have to actually write the getter and setter. I suppose I personally prefer just using accessors like X. Well, there's one thing about just relying on the accessors. I mean, there's still a difference between a public field and having getters and setters, in the sense of that a field is always by nature concrete. So that means there's no way to abstract that. There's no way to basically generalize that. There's no way to add additional logic, stuff like that. I mean, for these data containers, yeah, it wouldn't be a big deal, but oops. I mean, the yeah, Melon says, I use getters and setters a lot because I def WPF and WWE. I hope that's not the World Wrestling Entertainment. Okay, anyway. Use MVVM, so we are always implementing I notify property change. Yeah, obviously, yeah, that's exactly what I'm talking about. In that case, you can raise an event in the setter. So yeah, it basically has additional logic whenever that field is set. But like I said, it's not that the single purpose of the properties is to expose the data or to give mutability and immutability, stuff like that. It's also a way to have some sort of data contract and a way to abstract that, because fields are just data. There's no way to abstract data. Data is concrete by nature. But if you have a property with a getter and setter, or just a getter or just a setter is a little weird, but at least a getter, then you can always virtualize that getter, override it, stuff like that. You can't do that with a field. So it's always generally a good idea to have a getter and a setter, unless it's a very, very specific and simple case where you can justify it not to use one. But I think those occasions are very rare. Anyway, let's continue. Where was I? Object group, and I got the object data down. Wait, isn't it just an XML sequence? No. Let me see. Still not sure. Let me just check something here. Just a minute. Alright, anyway. So, yeah, object. We got that. Now we need the properties. Is it name or key? Name. Oops. Ah, what happened? Name value, that's fine. And it's in the object. Oops. Now I'm not sure here. Oh no, actually, should be fine, right? No, it's different. I think this is usually how the XML array expects the elements to look like. So you basically have an element that starts the array and then one element for each item. I think we're almost done, yeah. So the object can be a polygon, but it can also be a point or a rectangle. So in this particular instance, I don't have a rectangle, but I know for a fact that there can be rectangles. Maybe the element name will be rect instead of rectangle or something, but I think it's rectangle. So, properties, got that. It can be a polygon. What does the polygon consist of? Of a couple of points, obviously. But it's just a string in as the value of this point's attribute. I don't know if by default we can tell the serializer to deserialize that into some sort of collection, but we're just going to deserialize it into a string and then process that in our processor. There we go. Namespace, nullable. I guess yes, it is nullable because it might not be there. Is there also like an optional property for that? I don't think so. Let's just say, whoops, is nullable true. Point is completely empty. How are we going to go about that? I don't want an empty class, obviously. I guess I can just use a boolean. But that's not gonna work because it's not gonna set it true. So there's no way for us to indicate if it is a point. I mean, the simplest thing would be to have a point class. And the deserializer would, if there is a point element here, it would create an instance of the point class and assign it to the property here. And if not, if this doesn't exist, then it would be null. But it feels like kind of weird to have a class that is completely empty. Oh, I'm just going to use object. But I guess then it doesn't know how to deserialize it, even though it's completely empty. Because how is it supposed to know what instance to create? I mean, I guess I can just tell it. Wait, what's data type? Okay. Hold on, I think there's an attribute for that. Any element specifies that a member field that returns an area of contains objects that represent any XML element that has no corresponding member in the object being serialized or deserialized. No, that's not what it's used for. Technically, we only need to determine if this tag is present or not. Anyway. Let's see how the rectangle is structured here. Oh, okay. I just looked up the documentation here, of the official documentation of the tiled map format. And if the object is a rectangle, it doesn't actually have any element in it, because it's basically just a rectangle by default, because it already has a width and a height attribute, which is not used here. But if it's a rectangle, apparently it'll just set the object attributes width and height respectively, and that's it. Then I guess... Oh, this one isn't a rectangle. This right here. This is actually a rectangle object. Okay, then I guess we're done. I am not sure about this point. I'm not sure how to... I mean, there's nothing really to deserialize if the element is just empty. But let's see. I guess we can test that just with the unit test. I'll just copy that... Hold on. Copy the tile map here, test tiled map 1, go into the unit tests, Add a new unit test, rename it tile map data test. Deserialize. Let's just go here. Copy this. There we go. I guess we can just, in this case, copy this and then change it up a little. Come on. Why are you so slow? There. Tile map data, whoops. There we go. File stream is also in a different namespace. There. Oops. Now let's see, let's deserialize that, see how it turns out. I expect this to fail the first time. Yep. File not found, okay, okay, I forgot to change the build action. And also I need to add it here as a resource. Change this, copy of newer. Build action is content. And I started the game by accident. Debug. I think I already know here. Oh no, I thought I forgot the XML root attribute, but apparently not. Let's see if the magic works. File not found. Test tiled. Oh, the extension is different. Whoops. It's TMX. Oh. It's no. That's not good. Oh, we haven't deserialized it yet. Oops. There. Height 100, that's good. Layers 0, that's not good. And that's because the serializer expects the arrays to be basically in this format. And here it's just basically object, object, object. So I need to change that. Same for the tile sets. And the object groups are not even in there. I may have just forgotten the attribute. Let's see. Oh, I completely forgot to add the property for the object groups. Yeah, but this is not how it works. Basically, the array expects here the element name and the name of the items, the element items. So in this case here, the element name would be properties and the item name would be property. But I guess the object group in that case is just the XML array. But there can be multiple object groups. So how do we go about these sequences? So we already have the problem here in the tile sets. There's two elements with the same name, but it's not for the array attribute to work, the C# attribute XML array. It would basically have to be structured like this. And then the tile sets would be in there. But that's not the case, so I have to think of a different strategy here. I think I'm going to do a short break of like 3 to 5 minutes and I'll be right back, and then we'll continue and figure this out. So, be right back. Okay, I'm back. That was a short break. But anyway, now we're back. Let's get back to work. Let me just remove this title card and this little speech bubble. And you should be able to see the screen again. And I also just looked it up, and I think it's actually fairly simple. Instead of using the XML array attribute, we can simply say XML element, and there's no restriction here that there has to be only one element of this name. So this should work. But for the properties, yeah, here we actually do need an XML array because it's actually in the expected array format. Yep. This should be fine. But I need to specify here the name of the items. Element name. Pretty sure I need to wait, or do I need to? Element name, serialized array. Yeah, it's properties. Namespace order. I think it should work like this. Now let's debug this again. Okay, so now the layers are filled, that's great. The object groups are still empty though. Tile sets are filled. Okay, I made some mistake with the object groups. Oh yeah. And then in the object group, there are objects which should be XML element. Ah, I started the game again. Why do I keep doing that? And that was our ninja shouting. Oops. Ah, here again. No, this is fine. Should be good. I mean, let's see if this causes the problem. I guess it does. No. $110.18. Did I change? Hold on. $110.18. Yeah, that's not gonna help. I guess it's probably this. Ah, and I started the game. No, it can't be, right? Because it did work before. The string is in the wrong format. But how so? We didn't change anything about the file. That's fine. It's also fine. We didn't change anything about the file, so what's going on all of a sudden? Let's remove the objects. Because I think before that it was working. Yeah, so it's something about the objects. Object group. Object group, that's fine. ID, name, and then objects. Element name, object. That's fine. Why is width and height a string? I mean, this should still work, but it's weird. Ah, here. For some reason we made this the name an integer. So obviously that's not gonna work. Yeah. Should be okay. Yep, there we go, map data. Now the objects are in there too. It's one object group, which is fine. And there should be 1, 2, 3, 4 objects in that object group. But there's just one. Oh no, there's one object group and then there are 4 objects. Okay, that's fine. And let's see if one of them here, where's the one here? With the ID 14, if it has a point object, so basically just an instance of object, 14, there. Yes, it does work. So now there's just a simple, an instance of object. But that way we can indicate if the point is not null, then it is of type point. So that's fine. We can use that. So yeah, we're done with just encapsulating the data. Finally, I didn't think it would take that long. So now we can actually process the data. So let's go here into the pipeline extension. And let's write the logic for the processor, which will be fairly simple. I guess technically it's just exactly what we do here. But this is for the tile set, right? Yeah, this is for the tile set. Yeah, we simply, basically we do the same thing. So the processor is basically just the importer. So the importer is just supposed to read out the file data, and that's it. And then the processor is supposed to actually do something with that data. Not sure if the file name here actually refers to the full file path. Probably not. We're going to need the full file path, so let me see. No, I think it is actually the full file path. So let's use a stream here. The file mode will be open. And basically we do the same thing here. We need to reference that namespace. Oops, new blub, type of tile set data. And then just go return XML serializer. Oops. XML serializer. Deserialize file stream as tileset data. So now when we use the content pipeline tool, Let me just open it up. There. Now if we were to import a file with extension TSX, this importer would be called, an instance would be created, and the file name would be passed, and the logic would be called here. We need to actually specify here that the target file extension is TSX. Display name is how it will be displayed in the content pipeline tool. Let's say tile set importer. And the processor for it is the name of the processor class. Yeah. Is it the class name or just the display name? Probably the class name. Let's just say name of. There. And now we can do the interesting part. The input is tile set data, and the output is actually a tile set. So now we need to actually create our tile set class that we want to actually use in the game. So let's create a folder here. Tile maps, and in there okay, let's take a look here at the class diagram where I didn't include the tile set apparently, but that's fine. So what does our tile set actually consist of? Obviously we need the version we don't really care about. The name is probably important to a degree. Tile width and tile height is very important. And let's not make it possible to change that, because it might lead to inconsistencies. So let's keep this setter private. We might even make it read-only, but private will do. Tile count, very important. Columns. Don't know if we need that. We might actually just create instances of a tile class. Yeah, we don't really need that. Let me think. So basically we need to store the different identifiers of each of the tiles, because each of the tiles has a global identifier. But I guess for the tile set, I mean, what I was thinking here is we create a tile class, and then here I have a list of tiles. Or maybe call that tile set tile to not confuse it with a tile in a tile map. And each of the tiles what properties do the tiles actually have? Do we... I guess each tile can have width and height, but do we really need to store that? Because they're all the same width and height. It would be redundant to store that for each tile individually. Doesn't make sense. Not sure if we even need that. We might be okay with just the IDs. We changed the music. I find that to be a little bit annoying, personally. Let's go with this. So let's see. When we create the tile map, we will have to reference the tiles within the tile set. And for that, well, one obvious thing that the tile set needs is, is a texture. And let's say if here For example, here it says that the first global ID in the tile set, so the first tile in the tile set will be referenced with the global ID 51. So now I want to get that specific tile in order to render it. I guess what we need. Yeah, I guess it would be a good idea to store the first... Oh no, that's just a reference, hold on. I think I got an idea. I mean, technically the tile can be a complex object. A tile can be animated, a tile can have custom properties. Here we could technically, if we wanted to, here go and say, okay, let's say this particular tile here. We could, first of all, we could define terrains, which basically means like a coherent set of tiles that yeah, you can place like as it was a single tile, and it will automatically, for example, for the ground, it would automatically add the borders and stuff like that. We don't need that fancy stuff. We'll keep it fairly simple. So we don't need all of that. So I guess there's no need to actually have a tile class or a tileset tile class, because all we really need is the IDs. So let's remove this. Let's keep the model simple. I'm all for modeling it out properly and stuff, but let's keep it specific to our use case here. And actually do go with column count. And I think I'll actually make these immutable, so read-only properties. Column count, and what else? Tile count. So for this tile set here, well, actually for this tile set here, all we get is this. So apparently that's enough. And I think with the tile count, wait, hold on, did it say tile count 50? Tile count 50, and I think it does count the empty tiles, right? One, two, three, four, 5 by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, so it does count every single, even if there's no tile really here. So yeah. I guess we can just calculate the row count. By saying tile count divided by column count. And an integer division would be correct. No, it's not. We have to... Well, actually, it is. Yeah, that's fine. Now we need a constructor. Oops. Let's just generate it. It's easier, faster. Let's throw an exception if no texture is passed. Because it's not going to work without a texture. Yeah, and then we can say get tile bounce. And that's simple. Oops. Return new rectangle. guess x would be x multiplied by tile width, right? Y would be y multiplied by tile height. And the width would be just the tile width. And the height would be the tile height. So this way I can get the coordinates within the texture that I need in order to draw the tile. So let's say I want let's say I want to draw this tile. For that I would pass 0, 1, 2 for x, 2 for x, and 1 for y. So tile height times 1, that's right. Yeah, it should be correct. But let's also make it possible to just get the tile by ID and by its local ID basically. And I guess the ID should start with 1, since that's the way it's handled here. Let's say get tile bounds by local ID. And I guess for that, you can just say if we divide x by the column count, say 1, 2, 3, 4, 5, 6. Let's say we pass 8. We divide that by 5. Only we need to use modulo. So if we do 8 modulo 5, it'll give us 3 for x, which is not correct. We need to subtract 1 because the ID starts with 1. So we just go. So we pass 8. We subtract 1 and go modulo 5. That'll give us 7. Sorry, that'll give us 2. 0, 1, 2. That's fine for x. And for y, I guess we can actually just say tile ID -1 divided by column count and do an integer division. So if I pass 8 for 8, divide that by 5. Wait, no, I would first subtract 1, which is 7. Divide that by 5 would be 1. 1 point something, but it's an integer division, so it gives me 1. So yeah, it gives me this tile. That's correct. This should work. So now I can say return get tile bounds x, y. That's fine. And I think for the tile set, that's it for now. So let's go here into the processor. And now we need to turn that tile set data into a tile set. So we need to reference our Game assembly. What did I do? Let's reload this. I think we have a bit of a problem here, because our pipeline tool is .NET Framework as a target, and our class library is .NET Standard. Let's check something here. What's going on here? I think if we use that's a bit of a problem. Yeah, that's not gonna work. What type is our launcher? This should be a .NET Core, yeah. That's weird, because why are the MonoGame templates, why do they all target different .NET Framework types or versions? Yeah, that's not gonna work. I didn't think of that. Let me check something. Ah, it's because, oh yeah. Okay. It would be possible, but we're using .NET Standard 2.1 here in the standard library. But we need to because Box2D requires it. Let me just see. Dependencies 2.1. Maybe an older version? Yes, we can use an older version which targets 2.0 or 2.0. That would work. I hope that old version is stable. Because this way we can just target .NET Standard 2.0. Yeah, it'll show a bunch of errors now, but they should disappear in a second. And now that we're targeting 2.0, we should now be able to set this to 461, which will be fine. And that should do the trick. Yeah, it does. But let's just see, let me comment this out for a second. So now all the errors should be resolved, that's fine, okay. Let me just see if the physics still work, because now we're using a slightly older version of Box2D, and I hope that doesn't mess things up. No, it seems to be okay. Yeah, that's fine. Okay, good. So, no worries. We resolved it. Sometimes these different .NET Standard, .NET Framework, .NET Core, working with those different versions, it can be a headache. You shouldn't really mix that. I mean, .NET Standard is basically the interface for all of them, so if they all implement the same .NET Standard, they will be compatible. And that's how I made it compatible, because .NET Framework 4.6.1 implements the .NET Standard 2.0, so by just changing this to 2.0, they're compatible. So that's fine. Now, let's get to the processor and uncomment this. Now change the output to the tile set. Input will be tile set data. And it's fairly simple now. We'll just say tile set, new tile set, get the data from the input. Oh. Now we need the texture. For now, we'll pass null. Input columns tile count. There we go. And yeah, for the texture. Basically, that is a dependency to a file, because here we only have the source image as a path. So basically we need to load that texture from that path now. And we should be able to do that using the context object that is passed here. You could say context build and load asset. Let me just see what IntelliSense says. Initiates a nested build of the specified asset and then loads the result into memory. Not sure if we have to add a dependency first. Adds a dependency to the specified file. This causes a rebuild of the file whenever modified on subsequent incremental builds. Okay, I can basically say that this tile set is dependent on this image file. So if this image file changes, I will have to rebuild the tile set. I don't really need to do that, I think. But what I do need to do is say build and load asset, texture 2D. External reference. Oh. I will need to create an external reference to a texture. And that's in a different namespace. There. Yeah, now I can pass the file name, and that will be the file name from the input here. What's the second parameter? Relative to content. The content that the path specified in file name is relative to. Not sure if we need to specify that. think it should work. Processor name. The processor name we can find out by simply using the tool here. Wait, where's the existing content? It's just texture. Guess it's missing some arguments still. Oh, it needs two type parameters. The input specifies external references to data file for the content item. Where the object model is instantiated, reference file names are absolute. I mean, there's other ways we can achieve this, but I guess this is the way. You're supposed to be doing it, but I'm not sure. I'm not sure what the type parameter for the external reference should be. I figured it should be the texture 2D, but let's see if there's a documentation. Hello Danielle, welcome to the stream. We're working on implementing tile maps in our game using, basically we want to use the tiled map editor as an external tool to build our levels or stages and then import the tile maps using the MonoGame content pipeline tool, and then processing the tile maps so that they can be turned into game objects that can we use in our game and render the stage. So that's what we're working on. So the thing currently is that the tile set, when we import it, it has a reference to an external file, which is an image. And we need to tell the processor that it needs to also import that external file. Convert. I mean, another way would be to not pass the actual texture to the tile set here, but instead just pass the path. And then we could have a load method here where we pass the content manager and then we load it at runtime. But I don't know. I think it's better to do it this way, but I'm not entirely sure. I thought it was as easy as just saying build and load asset. Initiates a nested build of the specified asset and then loads the result into memory. Sounds great, exactly what we want. But I'm not sure how to properly create the external reference. I guess it might just be a string. Oh yeah, it's a keyword. Input image source. We don't need this. Then here texture to D. Input is string, output is texture to D. But I'm not sure if the input is actually a string. We'll see. I guess it depends how the texture file data is actually read. It might be read as a string and then turned into a texture 2D. Let's just see. We'll need to pass this texture here. And then return the tile set. And that's as far as the processing goes. We would then also have to implement a reader, a content reader in our game project or game assembly here. But for now, we should be able to go here and say content. First of all, we need to build this. Oops. Oh, that doesn't work. Oh, there's a... There was a parentheses missing. It's fine. Let's go build. Now in the content pipeline tool, we should be able to... First of all, let's close this here. Open it up again, and I think we should be able to where was it again? There are references, and I can add the assembly, the DLL of our extension. It should be 461. And where is it? This one. Now let's try we still should have our resources open here. Yes, copy this and put it here and say add existing item. Select this, and it automatically selects the tileset processor and tileset importer that we created. So that's working. It recognizes our custom importers and processors, or importer and processor. It's just one. But now let's see if it works. But I'm not sure about the external reference. Let's actually set a breakpoint. I'm not sure we can. I'm not sure we can attach the debugger to the content pipeline tool. We can't start this. This is just a library. but can we attach it somehow? I don't think we can, so this will be hard to debug. So hopefully we don't have to do as much debugging here. Not sure if there's a way to debug these. I wouldn't know how to attach the debugger here to our content pipeline tool. That doesn't work. Okay, so there's a problem with it. Failed to create processor texture. Okay, so the processor here I don't know what it's actually named. That's a problem because it's not a custom processor. It's a built-in processor from MonoGame. I don't know what that is actually named. It might just be texture processor or texture 2D processor probably. Ah, we might be able to find out if we just go to or MonoGame. Nah. No, we can't attach it to. Can we? I don't think so because it's not. Hold on. Yeah, we need to run the content pipeline tool first. I'll try that in a second, but for right now I know what is going on here. The processor, the name is incorrect. Might be texture 2D processor, I'm not sure. We have to rebuild now. Open the pipeline tool again. No, it's not called texture 2D processor either. But now that it's open, let's try to actually attach it. Debug, attach to process. Now, what's the name of this? Probably something like MG. MonoGame pipeline tool. I'm not sure what the process's name is. Can we find out? Wait. Let's just look it up. Maybe it's just texture processor, not sure. Maybe it needs the fully qualified name, including the namespace. Open. Is it pipeline.exe? I'm not sure. Nah. Oh, come on. Processor. Okay, now it's a different invalid cast. Ah. Okay. Okay, so what the processor returns is actually an object of type texture2D content. Wait, I guess we don't need to actually load it. Hold on. Let me check something really quick here. Let me test something. I just wanted to see what happens. First of all, let's go into the tile set and remove this throws statement for now, so I can pass null. Now, processor, just pass null for now. And rebuild the entire solution. Oh, what happened? Oh yeah, when I rebuild it, I think it's actually tries to rebuild the content as well. That's fine. So now it's building. And I think what it does now, see, it's actually successfully building the tile set. And I think what it does now is it also adds, where's the content here? I thought it would maybe, since I where is it? Here. Since I called it build and load asset method, I thought it would also build the texture and store it here in the content folder. Add output file. I need to now generate. No. Now we have this texture to the content object, but we need an actual texture. But it doesn't really make sense to have the texture, to basically turn this into a texture now, since that's what's supposed to happen when the serialized data is read back into an object at runtime. So let me just, I got an idea. Oh no, that's not gonna work. I was thinking of something, but no. I mean, we can always go the different route where we load the texture at runtime. Oh, it is pipeline.exe. But it seems like this will never be triggered. This breakpoint will not currently be hit. The source code is different from the original version. Yeah, that's... The thing is that the content pipeline tool just references the DLL. It doesn't actually... This is the DLL of the pipeline extension that we wrote is not actually the source of the pipeline tool. It's just referenced. So I don't think that's gonna work. Let's actually write the reader. Hold on. Let's not worry about this for now. Obviously, we need to solve this since the texture is important. It's basically the most important part of the tile set. But let's implement the reader. And actually, I'm not sure if we need a custom reader if it's just serialized to X and B, which is the default binary format. Let's check. Let's just go into the game class here and just try in the load content method, say tile set, which is in a different namespace. Test tile set equals content load texture tile set. Oh, the name obviously is test. Oh, that's the wrong project. Okay, so if we do, yeah, okay. We can use the default reader, but if we do so, we need to provide a parameterless constructor, a default constructor to the tile set. And I guess it can probably be even private, as long as there is one. Not sure. Or we can create a custom reader. Oops. Where is it? There. Yeah. Okay. Yeah, here we're dividing by 0 because everything is 0 for some reason. The name is correct, which is test. That's weird. Let's go here and say just for debugging purposes. When we go rebuild, it's fine. And now when we import it, it should log the imported data. Let's see. Failed to create importer tileset importer? What is that? Missing. Oh, whoops. It should have logged it somewhere. I don't see the log. Starting the build here, but it doesn't log the messages. Why? Debug mode. Okay, well, never mind. I think I'm gonna call it a day. We did quite a bit of work. But I'll take a look at this off stream, how I can maintain this external reference without needing to reconstruct it at runtime. Because I think, I mean, as a last resort, that will be a resolution. We could always just, instead of passing the actual tile set, the actual texture to the constructor, we could just pass the name of the texture or the path and then just load it at runtime. That's a possibility. I'd like to avoid that, and there must be a way to. But yeah, I've been streaming for 4 hours, and I think that's enough for today. Thank you everyone for joining. It was really fun today again. And yeah, I hope you will join me next time. I will likely stream tomorrow. Don't take my word for it though, I don't know what will... I have nothing planned tomorrow, but I don't know what will come up tomorrow, so we'll see. But I'll announce it in time. And also I have to release the new video in the T-Rex series. I guess I'll have to render that tomorrow. So hopefully that'll be out tomorrow evening, but we'll see. So thank you everyone, and see you next time. Bye.